All right, this video is to go over the trapezoids homework assignment. So let's start right here. In question one, we have an isosceles trapezoid. We know that because the bases are parallel, the legs are congruent. So when the legs are congruent, it's isosceles. Um, and it's very similar to an isosceles triangle. The legs are congruent, the base angles are congruent. So in our trapezoid, we have legs here that are congruent, and the base angles are congruent. The two angles that sit on the same base are congruent. Angle Y and angle Z are also congruent because they are base angles. So when we find one, we'll know them both. The way we can find it, and it doesn't matter which side of the picture we work on, parallel lines cut by a transversal. So consecutive interior angles are supplementary. So we get 115 for Z and 115 for Y. $65 plus X equals 180. In the next question, we're looking for a pair of angles. And again, since it's a trapezoid, we know that the bases are parallel. Let's find our transversal and the alternate interior angles. Are congruent. So we're just going to bring our 20 degrees down. Now for angle 2, we can do this two different ways. We can work on that triangle. We know 20, 110, and we're looking for angle 2. The angles of a triangle have to add up to 180. We could also go back to our parallel lines cut by a transversal. We have consecutive interior angles. So one approach is the triangle adds to 180, or the second approach is consecutive interior angles are supplementary. So we have 110 plus the 20 plus angle 2. And we get the exact same total of 130, and we get the exact same answer for angle 2. So we have two different approaches. Very similar question. So the first thing we're going to do is our alternate interior angle. Now in this question, what we want to do next is we're going to say, since it's an isosceles trapezoid, the base angles are congruent. So that's the property that we're using. So the 55 on the left is equal to the 30 plus angle 2 on the right, and we get 25. So we have our trapezoid. That median or mid-segment is drawn in. It is important that we remember the bases are parallel, and the median or mid-segment, it's the same thing in a trapezoid, is parallel to the bases. We're given angle E is 65. and we're asked to find a few other things. Well, something else that we're given is really important. EH and FG. EH, let's find them in the picture. Here's EH, and here's FG. Now, we're told that they're equal to each other. In the picture, they're marked differently, but the directions told us that they're equal. So not only are they both equal, but J and K are their midpoints, which means they're both bisected. But we want to add that. We want to add that fact that they're equal. So I'm going to mark them all the same. Because now, even though it wasn't shown in the picture, in the problem, they're telling us that this is an isosceles trapezoid. They're telling us those legs are congruent. That means that the base angles are congruent. So they asked, the first thing they asked for was angle G, and that's on the other side of the picture. The 65 is on the left, but angle G is on the right. Well, knowing, I'm just going to make this a little bit bigger, knowing that that it's an isosceles trapezoid lets us move the 65 to the other base angle. Remember, each pair of base angles are congruent. Now that they're on the same side of the picture, we can see that we have parallel lines cut by a transversal. So the 65 and the angle G are supplementary. They are consecutive interior angles. So they're supplementary, and we get 115. Now the next question, angle GKJ. So let's find it. GKJ is right here. Well, again, that median or midsegment is parallel. So we can say that the 115 angle G plus angle GKJ is 180, again, because they are consecutive interior. And we already know angle G. So we get 65. Another way to do that is that angle F is congruent to angle GKJ because these are corresponding angles. So let me just draw that parallel line in so we can see it better. Angle F, 65, and angle GKJ are corresponding angles. So another way to do it. Again, more than one way, but we have to know our angle pair relationships. So here we used corresponding angles or consecutive interior angles. In this question, we're working with the bases and that median or midsegment, and we have one formula for that. The median of a trapezoid equals 1/2 the sum of the bases. So we're going to work that out. Combining like terms, looks like 3x minus 10. Now, algebraically, you can handle this two different ways. You can multiply both sides by 2 to cancel out the 1/2, or you can distribute the 1/2. So if we multiply by 2, we're going to treat this like it's in parentheses. Right, so that's our multiply by 2 option, multiplied by the denominator. So that's one approach. 2x plus 2, 3x minus 10, and we get x equals 12. A second option is to distribute x plus 1 equals 3/2 x minus 5. We still need to get our x's and our constants to different sides. And now we're going to multiply by 2. And we get the exact same answer, x equals 12. So one formula for geometry, median equals 1/2 the sum of the bases, but two approaches algebraically. Let's see, we have an isosceles trapezoid. Again, those legs are marked congruent. Let's find the parts, EC, so that's a diagonal, and FD, that's the other diagonal. In an isosceles trapezoid, the diagonals are congruent. So we can find x. That's not right. Sorry. We had to add 10. See what happens when you don't write out your work? Always show your work. Again, we're working with the bases and the mid-segment or the median. So again, we have one formula. Don't change the formula. Plug things in and then execute your algebra. So median equals 1/2 the sum of the bases. Now we can perform our algebra. Again, just like before, we've got two options. Multiply by 2, and we get 11 equals x plus 4.4. Subtract 4.4, and we get 6.6. The other option algebraically is to distribute 5.5 equals x over 2, or 1/2 x, plus 2.2, subtract 2.2. That gives us 3.3 equals x over 2, or 1/2 x, and then times 2. So 6.6 equals x. So we get the same 6.6 either way. One formula for geometry, and then two ways of executing our algebra. We're told MATH is an isosceles trapezoid. So just like we discussed in the lesson, we have to be a little careful how we draw this. Which are the bases and which are the legs. So draw something that looks like an isosceles trapezoid. Start at one corner and go around it. MATH. And now check to make sure that it's correct. AT is parallel to MH. Well, that's not true. So I'm going to fix it. And we said we can shift the letters or we could just go in the other direction. But we have to get the letters in an appropriate place. I'm just going to go in the other directions. MATH. Now I have AT parallel to MH. Now it's correct. We're working with angle M and angle H. These are base angles of an isosceles trapezoid. Base angles are congruent. If our letters were in the wrong spot, we would not have realized that they were base angles. We would have had them as consecutive interior angles. So getting those letters in the correct spot is important. So always make sure that your picture fits the words before you try to solve things. And in our last question here, we're asked to classify the quadrilateral. So we're asked, what is it? So since we're on the coordinate plane, we're going to plot a few points. -1, 2. Let's see. -1, 2, 3, 0. 1, 2, 3, 0. 4, -3. 4, 1, 2, 3. And -4, 1. 1, 2, 4, -1. So that's my picture. Now, is my picture perfect? Of course not. Do I start to have an idea of what it is? I do. I have an idea. It doesn't look like a parallelogram. It looks like it's closer to a trapezoid. But I need to find out. I need to make sure. So we should have labeled our points W, X, Y, and Z. So think about what are the properties. That's what this means. What properties can we figure out are true? Well, one of the easiest things to do is slope. Parallelograms and trapezoids have parallel lines. So we should find the slope. We only know how to do a few things. What do we know? We know slope, we know distance, and we know midpoint. That's all we know. So let's try things. Let's find the slope of WX. So that's 0 minus 2, 3 minus -1, -2 over 4, -1/2. And now we can find the slope of ZY. Let's find out if the opposite sides are parallel. If the opposite sides are not parallel, then the answer is cannot be determined or nothing. Like it's not any of those shapes. So again, we have y2 minus y1, x2 minus x1. It looks like we have 4 over -8, which is -1/2. So these are parallel. So let's add that to the picture. So right now we have one pair of opposite sides that are parallel. We should also check the other pair. One pair of opposite sides means it's a trapezoid. Both pairs means it's a parallelogram. Now, it's pretty obvious from the picture that the other sides are not parallel. We should certainly check it. That would be good, but it's clear from the picture. So far, this thing is definitely a trapezoid. It can't be a rhombus because that requires both pairs of opposite sides parallel. Well, sorry. Okay. So it can't be a rhombus because it requires both pairs of opposite sides of parallel. Now, again, I'm not showing the calculation for WZ and XY, but from the picture, we can see they are definitely not parallel. So it can't be any kind of parallelogram. So it's not a rhombus. It's not a square. It's not a parallelogram. It's not a rectangle. So far, we know that it is a trapezoid. So I'm going to cross off cannot be determined. So with a very quick slope calculation, we already know it's a trapezoid. Now, what makes it isosceles? The legs are congruent. Congruent is distance formula. They're the same length. We also know that the diagonals are congruent. Again, distance formula. So what I might do now is find the distance of WZ and the distance for XY. If they're congruent, then it's isosceles. If they're not congruent, then it's a regular trapezoid. So now we need our distance formula, and we're going to use the points W and Z. So our distance formula for W and Z, so we have -4 minus -1 squared plus 1 minus 2 quantity squared. -1 plus 1 is -3. -1. That's 9 plus 1 for the square root 10. I'm going to do the same thing with x and y. 4 minus 3 squared. -3 minus 0 quantity squared. Well, that's 1 squared, -3 squared. 1 plus 9, square root 10. So these two are congruent. So I'm going to add that to the picture. So I have one pair of opposite sides that are parallel, the bases, and I have the legs are congruent. The answer here is isosceles trapezoid. All right, so that's our homework assignment from the other night. Finish up today's work. Keep moving forward.